Welcome to a lesson with Dr. Powell. Let's take a look at this series now, and we're going to look at a test for convergence or divergence, a test for absolute convergence or divergence. That's different from the ratio test. We're going to look at something called the root test. And again, it compares things to how a geometric series might be behaving. Okay, so remember that a geometric series looks something like first guy and then like r to the nth power. Now, if we were to just look at these guys and take an nth root of that, notice that we get nth root a naught times r. Now, and r is kind of the key. If it's less than zero, or less than one, or greater than one, we can kind of test for convergence, at least with the absolute value of r. But think about the nth root of a naught. As n goes to infinity, this is a naught 1 over n. This exponent's going to 0. A naught to the 0 is 1. So this part is going to 1. So this limit in general is going to r. So for a geometric series, it makes sense that if you take the nth root of this and take a limit, you'll actually recover what you're multiplying by from term to term. You'll recover that ratio r. Now, intuitively, it makes sense. Well, what if we take an nth root of this and consider it, and if it has a limit, then we're good to go. If that limit is less than 1, then it should converge because it should be similar to what it happens for a geometric series over here. And we'll make this statement rigorous, but kind of intuitively it makes sense, so that's what should happen. Now, let's think about taking the limit of the nth root of this term here. Now, if we take an nth root already, this nth power goes away, so we're just left with the inside. We can take the limit inside the cosine, which is continuous, and notice that the limit of the inside, this is a polynomial over polynomial. Leading term is pi n, leading term is 3n. The limit just ends up being pi thirds. And so the limit is so we have, the limit will just simply be cosine of pi thirds, because when we take an nth root, this goes away, and we're just taking the limit of the inside here. So we get cosine of pi thirds is the limit as n goes to infinity, and cosine of pi thirds is simply a half. So an r value of a half, we should expect that this series actually should converge. Okay, because it should be somehow related to a geometric series that has an r value of a half. That's the intuitive version of this root test. Now let's kind of look at this specifically. Let's call this a sub n, and and we know that the nth root of a sub n limits to a half. That means eventually, when n is large enough, so past a certain point, then we know that the nth root of an is going to be fairly close to is going to be fairly close to let's see, 1/2 plus epsilon, or it's going to be a half minus epsilon. So so if you go far enough, given a particular epsilon value, like set this, then given this a tolerance value, a really small value, you can make epsilon as small as you like. But once you fix it, then there's a some point that if you go past it, then this guy is going to be only that far away from a half from the limit. That's what it means to limit. We're getting close to a half. So eventually we're going to be pretty close to it. We're going to be within so far away. Now, in this inequality, we can raise everything to the nth power here. And notice that we have eventually that a sub n itself is sandwiched between the terms of two geometric sequences. and epsilon is pretty small, so we can be sure that these geometric sequences have R values within the range of absolute value less than 1, as long as this limit here is not 1. If it's 1, then we don't know. But so this test is a lot like a ratio test. When the limit is 1, we don't know. However, if the limit is something like a half, we're pretty good here, because we're sandwiched between the terms, are sandwiched between two geometric series terms, and that'll guarantee convergence because we're actually comparing quite literally to a geometric series by virtue of the idea that we're limiting to something that's we're limiting to something like an R value, which is like an R value that's close to what we'd have in a geometric series. So hence, all we do in summary to if we have a series and it's easy to take the limit of the nth root. So let's suppose we have a series like a sub n, and we're going from something to infinity. Well, maybe not a, but maybe let's just say m or something. Okay. Then if it's easy to take this limit, and we notice that this limit, and we're going to be taking absolute values, of course, this is an absolute value convergence idea. So we take that, and we take an nth root of this, and it goes to a limit L. And if we know that the limit here is less than 1, then we have convergence. In a very similar way, if absolute value of L is greater than 1, then we will have divergence. Thanks for watching.